So I've got a couple people that have been asking me, wanting more help on the exam than I really want to give. So what I'm going to do is I'm going to walk you through one of the optional discussion forum prompts that I made available last week, and hopefully this will let you give you enough idea on how to do exam questions, quiz questions. Okay, so this is about frozen orange juice, and it says a producer of frozen orange juice. Let's see here. Let me get my mouse working. Here we go. It says that the producer claims that 20% of the frozen orange, let's see, 20% of all orange juice drinkers prefer their product. Okay, so that's the claim. So claim is that 20% or more choose their product, prefer their product. And that's if I could spell your OJ. All right, so that's the claim. So I guess we had to decide. I'm not seeing any kind of discussion about a standard deviation or anything. So I suspect this is about proportions. I see that they went out and they did a sample, and they found, so these are the competitors. The competitors went out and did a sample, and they did 200 drinkers and found that 33 liked that. So that's p hat. That's the sample proportion. So what does that equal out to be? Let's see, 33 divided by 200. So I'm getting 0.165. Or 16.5%. Just a minute here. Let me do this right. Now, what if I had been miserable with this problem and I hadn't told you that there were 33 out of 600 or out of 200, but I told you that there was 16.5% of the 200 liked the OJ. So how could I get the 33? Well, 0.165 times 200 is 33. So that'd be the other way to deal with this if you needed to. Certainly for the applets, you would need to know the 33. Okay, now how do I know this is valid to use a one proportion z-test with this? Well, if you look in Dr. Stevens, I had to make sure I wasn't going to do anything confidential, show anybody anything confidential. So I see this requirement. And P has to be bigger than 5, and N times Q, and Q, remember, is 1 minus P, also has to be bigger than 5. And as long as that's true, and we get a binomial distribution, and we get a random sample, we're okay to use a one sample, one proportion z-test. So let me come back to this. Let's see, we've got a random sample. They don't tell us it's random. I guess we'll assume it is. Does it satisfy the binomial distribution? Well, let's see. I'm going to assume that asking whether one person likes their OJ or not is independent of the next. Sounds like the probability would stay the same if they're claiming that, here, where's my pointer? If they're claiming that 20% or more are like the OJ, so we can say that any one person, there's a 20% chance they'll like the OJ, and that stays the same from person to person. So what I'm trying to go with is this satisfies the binomial distribution. It's do you like the OJ or not is a yes/no answer, so that works. What else? Oh, and then let's see. So the independence, we've got the probability stays the same. It's a yes/no answer. I'm missing one. What is it? Your independent. It's a yes/no answer. There's a fixed number of trials. 200 drinkers. So we're good. We've got a binomial distribution. Now we've just got to decide, is it okay to use that normal approximation to the binomial distribution we studied back in chapter 7? Well, that N times P thing kind of is what helps us. remember in the book it said, here, let me come back here. It said n times p has to be bigger than 5, or n times 1 minus p has to be greater than 5. So we've got 200, we've got 0.2, that's going to be what, 10? No, 10% would be, that'd be 40, won't it? 10% would be 20, and two of them, right? And then 200 times 80, or 0.8. Well, if 0.2 times 200 is more than 5, 0.8 times 200 will be more than 5. So we've got that good. Now, why do we need to have that? Why is this sufficient to say it's good enough that we can use a normal approximation to the binomial distribution, or safe to use this statistical test? Well, one of the applets I made available to you folks was this histogram applet. And for this problem, if I type in a 200 trials and the probability of success is 0.2, see how this distribution works out to be a nice normal curve? So that's what happens when you do satisfy that n times p is bigger than 5. You get a normal curve. You can use a mean. You can use a standard deviation and go for it. Just so what happens, so what if I only had 10 individuals instead of 200? And see how this distribution is not normal? It's kind of right skewed. So that's why, and 0.2 times 10 is what? Is 2. So that's not, see how that's not bigger than 5? What if we made this be 20 people, 20 individuals? 0.2 times 20 is 4. It's better, but it's still going to skew, right? So if we want to do 1/5, so what about 30? What if we kick up to 10? Because that's why I'm making this video, really, because I wanted to make this. That's better. That's more normal, but it's still not great. And 30 times 0.2 is 6. What if we do 40? I hope you see where we're going with this. It'll get better, but it's still skewed. 0.2 times 40 is 8. How about if we go to 50? That's looking much better, but still, I think it doesn't say greater than 5. 0.2 times 50 is 5. So it still has got a little bit of skew going on. What if we make it 60? Now that still is a little bit more, but it's looking much, much better. And then of course we had what, 200? So clearly a normal distribution. So we satisfied that condition to say it's safe to use this test. Okay. So then you can either do calculate a z-score, find a critical value or whatever. I could also just use an applet here. Let me go to Rossmann-Chance. You knew I was going to go do this, not Rothschild. Rossmann-Chance theory-based. Here we go. So it's a 1 proportion. I've got 200 people. I've got 33 that didn't like the juice or like the juice. I'm going to do a significance test. The claim was 0.2, and the guy's claim. Actually, maybe what we'll do is we'll make it be less than. There we go. So I'm getting that. There's my z-score, and there's my p-value. Let's see here. Then what I'm going to do is I'm going to capture this and pull it back to my sheet, just so we can talk a little more about this. Copy. Here we go. And let me pull this down so I can see it. So I think I can cover up some of this. There, that's good. That's good enough. So I've got let's see, where's my pen? I haven't done HO and HA formally. I did here. HO is the population proportion is equal to 0.2, but this in English this really means 0.2 or better. We're the competitor. We're trying to make a counterclaim. We're going to say, hold on, it's actually less than 0.2. And I kind of knew I wanted to go this way because that p hat was less than the 0.20. If it had been more than the 0.20, well, they probably would be making that case, but I would probably have to go with a right-tailed. Okay, and then here's my test statistic. Here's my p-value. I'm gonna fail to reject HO because that's much bigger than their 10% level of significance. If they hadn't given this to me, then I would have used that whole if somebody's going to lose a lot of money or die because of a bad decision, use a 1% level of significance. If it's just if that isn't the case, just go with a 5% level of significance. Okay, and then of course if you tell us, well, then that's a moot point. Okay, and then you just want to make sure that you write a conclusion. You can use the boilerplate they gave you. So I guess this will help you do this. Do the quiz now in particular, but get a little more flexibility or more practice with these kinds of significance tests.